Okay, so this is how you do problem number 6 on the Unit 3 electric potential homework. So the problem is very, very conceptual. It doesn't really have that many numbers. It basically asks you to use your prior knowledge to solve for the formulas that we've been given in this unit. So part A of number 6 asks for the show that the work required to move plus Q, I put that in red, plus Q charge from the negative plate to the positive plate is given by W equals Q, which is a charge, E, which is the field, and D, which is the distance. So from our mechanics unit, we know that work equals force times displacement times cosine theta. In this case, theta is 0, so cosine theta is 1. And we know that in terms of E and M, force is the charge times the electric field. So we change F to QE and we change delta X to D, which is basically the same thing. And we get work equals QED. And that is the answer to problem A. So for part B, it says use your result in A to get the definition of the electric field. So we, from this unit, we know that the electric potential is work divided by the charge. And we also know from part A that work equals charge times electric field times distance. So I basically manipulated this equation first. So I solved for work in terms of V and Q. So I multiplied Q to V, and then I set these two equal to each other. So you can see VQ from here and QED from here. And then I saw that Q was a common term, so I just canceled that out on both sides, and I got V equals ED. And then in this case, we're solving for the electric field, so I divided both sides by D. And this is what I got, E equals V over D. And that is the answer that they want you to get. So part C requires unit analysis. So you do have to recognize that the electric field is given by V, electric potential over D, which is a distance. So V volts over meters. And at the same time, V is equal to electric field times D, which is electric field being given by Newton per coulombs and D being given by meters. So if you substitute V with ED in this initial equation, you get E equals ED over D, which is basically like, say, Newton meter per coulomb divided by meter, and then you get Newton per coulomb, which is the unit that you want. So yeah.